Hello viewers, tutorial 14, question 11. So we have this applications of calculus question. We have a box which has a volume of 100 cubic centimetres. If it has a square base, what dimensions give the box its minimum surface area? And we also need to find what that minimum area is, assuming that the box has a top. So let's begin by drawing the diagram. So let's draw our box. So let's say that this side has a length of x. It is x deep. These two sides, this width and the depth here, have to be the same because that's where the square base piece of information comes into play. The height, however, may be different, so let's call that height h. Now its volume is given by its width times its depth times its height, which is x times h, which is x squared times h. The volume, we're told, is 100, and that gives us one equation. We also need to get an equation for the surface area of the box. So what's the surface area going to be? First of all, it has a bottom and a top. Let's look at the top. It has a width of x and a length of x, so it's x squared. That's the top. The bottom is exactly the same, so there'll be two of those. Plus, now what about this front? This front has a width of x and a height of h. And the four sides, the front, the back, the left and the right, will also be the same, so that is going to be, there are going to be four of those, 4xh. So our area is 2x squared plus 4xh. We will need to minimise that surface area, which means we will need to differentiate. But as it stands, we can't differentiate yet because we've got two variables involved. So we need to eliminate the h from this equation, and that's how we use the volume equation. So from the volume equation, rearrange to solve for h. So we have h equals 100 divided by x squared, and sub into our equation for a. So if we do that, we get a equals 2x squared plus 4x times h, which is 100 over x squared, which is going to be 2x squared plus 400 x over x squared, so that's going to be x to the power of -1. So we've got a form that we can use to differentiate. We can differentiate that function, so let's go ahead and do that. So if we differentiate that, we get a dash equals 2x squared differentiates to 4x, 400x to the -1, well, 400 times -1 is -400, x to the power of -2. And because we're trying to find the minimum, we've got the derivative. We need to set that equal to 0 and solve this resulting equation. So we've got 4x equals 400 x to the -2, which is the same thing as 400 over x squared. And if we divide both sides of that equation by 4, we'll get x equals 400 divided by 4 is 100 divided by x squared. So let's now multiply both sides by x squared, and that gives us x cubed equals 100, and we can solve that by taking the cube root of both sides. So we get x is the cube root of 100. And if we calculate that, we get an answer of 4.61 centimetres. So we've found the value of x. Now we need to work out what we're looking for. First of all, the dimensions. Let's pay attention to what keywords are in the question. What dimensions give the box its minimum surface area? We've got this dimension, we've got the width of the box, but we now need to get the height of the box. We know that h equals 100 divided by x squared, and we now know what x is. So we get 100 divided by 4.61 squared, which is also 4.61. So it turns out the dimensions that give the box the minimum surface area is when it is exactly a cube. Okay, now we need to find what that area is. So we can substitute your values of A and H into this equation, or we can substitute just the value of X into that equation, either or, because really this equation was obtained by substituting H in anyway. So we've got area equals 2x squared, which is 2 times 4.61 squared plus 400 multiplied by 4.61 to the power of -1. And if we calculate that, we get 129.3 centimetres squared. Okay, thanks for watching. Over and out.